Alrighty, well, welcome and good evening. We are delighted to see you here, and we are really pleased this evening to have a great guest to wrap up our speaker series for this academic year. This evening is going to be, I think, really interesting because our speaker is Rashmi Banthia, who is an expert in Kaggle, which is an incredible community, an incredible platform for machine learning competitions. And she is here to talk tonight about her experiences and to talk about the kinds of opportunities that it offers to people who are interested in learning more about data science and applying their skills. So thank you, Rashmi, for joining us this evening. I'll hand it over to you. And as I remember from the plan, there'll be time for questions at the end. So we're looking forward to your Q&A afterwards. Thank you, everyone, for being here. Over to you, Rashmi.
Thank you. Thank you so much for having me here. And this is my favorite topic to talk about, so I can keep going. So I have a question for everyone. Do y'all have Kaggle accounts or have you heard of Kaggle?
Yeah, I think I do have a Kaggle account, and it's for kind of downloading data sets and things for the projects that I have had for my master's program in data science.
Right, right. Okay. So while I get started, it would be great for you guys to create a Kaggle account. It's free. You can go here, kaggle.com. I'll put the email. But yeah, so you can actually, I'll be giving a demo later on, so it'll be kind of useful to have an account, and rather than just watching me, you will be able to do it with me also. Uh, okay, great. So you can create an account. I think they need a phone verification, and it should be easy to create an account. So let me share my screen and the slides. Okay, how to learn from Kaggle competitions and more. So I'll be talking a lot more, everything about Kaggle basically. My experience is mostly competitions, so there'll be a lot more of competitions track as well. This is me on Kaggle. I am teaching fellow currently for quite a few data science, AI, ML classes at Harvard. In the past, I have done some consulting work, and I have a master's in computer science, which was in previous lifetime. So more recent is Kaggle and teaching. So today we are going to talk about why Kaggle, different Kaggle tracks and tiers, data sets, notebooks, discussions, competition, a demo, a little bit behind the scene for a competition. Feel free to interrupt me if you have any questions, but I'll keep going otherwise. Why join or why Kaggle? So Kaggle has like 24 million users. You will find all sorts of cutting edge tech as well as old tech on Kaggle. There's a lot to learn. You can compete and learn. You can showcase your work. Uh, you can build up your profile, collaborate with wonderful people, uh, and super interesting data sets sometimes or often. Uh, People also post solutions, which are there's quite a bit of information to learn from the posted solutions as well. There are four main tracks for Kaggle: competitions, notebooks, datasets, discussions, and models. Models are new. Uh, all the tiers that people talk about, the expert, the masters, the grandmasters, are all for these four tracks. Competitions, notebooks, datasets, and discussions, but not for models, at least not yet. So there are four tiers. I only put three because the fourth one is really easy to get it. I think you just have to make a post or upvote or something like that, and you become a fourth uh, Kaggle tier. It's a contributor tier. So this is the hardest one. I'm here right now. This is a bit easier than the master. And every tier requires, for every different tracks, like these competition, notebooks, discussion, and datasets. For example, for the expert, you're going to need 2 bronze medals. For the notebooks, you need a certain set of upvotes on certain set of notebooks and the similar things for discussion and data sets. For the Grandmaster, you need a solo gold medal, as well as you need 4 gold medals with the team for the competition track. The notebooks, the discussion, and the data sets rely on community upvoting. That means if your notebook is really good, you'll get a lot of upvotes. And it does happen. Whereas in competition, it is totally relying on your performance on the leaderboard. I highlight this is the progression tier, what you need, how many medals you need, but they have the whole list in this link. So for example, you need 2 bronze medals for the competition. If you want to be like data sets, Grandmaster, you're going to need 5 gold medals on the data sets as well as 5 silver medals. For everything, they have a whole list of things. So Kaggle has this notebook, Kaggle in numbers. This is like last 2 days back. They keep it up to date. 24 million Kaggle user accounts. First competition was in 2010. $29 million awarded in prize money. There are 1.4 million public notebooks by 435,000 authors. That's a lot of notebooks. Most of them are in Python, few in R as well. 475,000 public data sets as well. With so many things that are public, it becomes hard to find exactly what you need. But if you keep looking at it, it becomes easier also. It won't be so hard. Kaggle has like 616 grandmasters across all 4 categories. There are 10 grandmasters who are in all 4 categories. They are grandmasters. That is competition, notebook, datasets, as well as the discussion. It takes a lot of effort to get there. It has 2,900 masters and 120 twice masters. I'm in one of those 120 people here. It has 19,000 experts as well. So we start with datasets. It's the most popular. A lot of people use it. They have a lot of datasets. You think of a topic, you're going to find a dataset. It is very easy to download, upload the dataset. You can publish your own datasets. The interface and all is super easy. It's not complicated. They also give you free storage, private storage of 214 gigabytes. If you want to keep dataset private, if you want to share it, let's say you're working on a project, you want to keep the dataset private between you and your teammates, you can do that. You have max 214 gigabytes free available for you. Once this is full, you'll have to delete your dataset and you can go back and add some more, or you can make it public. It doesn't count towards your quota. So let's say I upload 100 gigabytes of my private dataset, but I want still more than, let's say I want to upload 300 more gigabytes. I'm going to have to make things private or make things public, which doesn't count towards your quota. So at the max, you can get this much private storage. They have a dataset called Kaggle Meta, which is kind of really cool. It is dataset about the dataset or about Kaggle. So it'll have all the competitions, discussions, all the users information, whatever is public, it's available in this Meta Kaggle. You can use this dataset to basically do a lot of things. I just highlight a few, but people use it for a lot of things here. You can summarize all the discussions. Let's say you find a topic, you search the discussions, you have the links, you will find all the discussions in one data set. You can take the data set, you can process it, send it to a maybe LLM, it'll summarize the things for you. You can get the kernels also. You can get users' informations also, who's participating in what competitions, things like that. You can do it. Sorry, I went back. Notebooks. There is so much information out there, and some of the notebooks are so good. Most of my learning happens with the notebooks, and I read them. I try to understand quite often what's going on in the top notebooks in the competitions. You can schedule, we'll see some of the notebook features later on during the demo. You can schedule notebooks to run automatically, daily, weekly, put it on a schedule. At one point, I had some work thing and I put a private Kaggle notebook to be scheduled every 2 days or every week. And it'll automatically run and it'll just send you the output, which is kind of cool. I mean, you don't have to worry about it. It's like a schedule a cron job. Every notebook also gets 20 gigabytes of free storage. That means within the notebook, you can generate 20 gigabytes of data and save it. So I use this often. I have, the way I use it is, remember I told you that we have 214 gigabytes of private space. If I run out of that space, 214 gigabytes, I use this free space. So it's kind of like unlimited and I use it. Nobody cares. Everybody uses it. I have like 4,000 notebooks, private, each with this much amount of data. I think one day if Kaggle finds out, they're going to delete all my notebooks. The cool thing is you can go from notebooks to datasets. Like the output of the notebook can be directly transferred to a dataset by just one click, which is kind of very cool. Kaggle also gives you free 30 hours of GPU. It can be P100 or twice T4 every week, no rollover. So if you use it, use it. Don't use it, you get 30 hours again. They recently introduced extra quota for Google Colab users. I hear students have pro accounts here. You can actually get extra GPU hours on Kaggle, like either 45 or 60 hours, depending on the pro, or the next level is plus, I believe. So depending on what account you have, you can get more quota in Kaggle. They also have GitHub integration. I've used it. It's not perfect, but it's there. We'll do a demo a little bit later. Our discussion, you can connect, collaborate with the community, just follow guidelines, no spam, no AI generated answers. Usually you don't put, if you like a post, upvote the post. You don't go and put thank you for sharing, or every 100 posts, you're going to be probably banned if you put thank you for sharing 100 times in 100 different posts. And people do get banned for not following the guidelines. Models are also cool. So these models are very large, like Gemma, Quen, Llama. If you were to upload on your own, it's a hassle. Everybody uploads like 15, 20, 30, 40 gigabytes of data. So they are putting the models on Kaggle itself, so you don't have to upload it on your own. You can directly use it from Kaggle. Competitions. So this is my favorite track of all. You have featured competitions, you have analytics competitions, you have playground and efficiency tracks. Featured competitions are the ones that gives you medals, the gold, silver, the bronze for the different tiers. Analytics competitions gives you money. Oh, featured gives you money as well. And the medals, both. The analytics one gives you money, but there are no medals. Playground ones also no medals, no money, but they give you swag and there's a lot of learning. If you're new, these are great ways to get started, to understand what's going on. And people share a lot also in play. They're more open to sharing because there is no medal or money at stake in playground competitions. Then there's an efficiency track, which are like you don't want inferences running forever. You want faster inferences. That's when the efficiency tracks come in. For this also, a very few competitions have that, but they don't award medals, at least not yet for these ones. You will find all sorts of competitions, text, that's LLMs, computer vision, healthcare, audio, tabular, sports. Some of these competitions are repeated. For example, Birdcliff audio competition, it's repeated every year. So if audio is your thing, you should do this every year. Similarly, March Madness, also repeated every year in March or April sometime. They just keep going. So some competitions are like repeated every year, but quite often you are going to see new competitions and new topics all together. People implement cutting edge tech, implement research paper. There is no limit as to there are certain limits in the sense for the inference. That means there is no internet allowed for the inference. So you can't call OpenAI, hey, is this the binary classification true or false? You can't do that. So no internet allowed in the inference. You also have limited inference time, like some competitions have 4 hours, some have 9 hours. And the inference compute is provided by Kaggle. That means you submit your code, Kaggle has the data. They'll take your code, they'll take their data, run it, and give us the results, how we did. So this is what the submit via code kernels, that is submit code, test set remains hidden. So they don't give us the test set. We only submit the code. We don't get to see the test set. We only get to see the training set. Most competitions, featured ones are like this. The ones in the playground are going to be where they give you the test set and you submit everything. Like usual, creating a CSV file and you submit it. Oh, the very important rules for the Kaggle competition is, excuse me for a second, no multiple accounts. That means you should not create multiple accounts on Kaggle. You should not also private share. What that means is if private sharing across the teams, that means I'm not sharing my code with another team. So let's say Emma is in another team, I'm in another team. I'm not sharing my code with Emma, unless Emma and I are both in the same team. So people get banned from the competition. What happens is if Kaggle finds out that I shared, not only I'll get banned, Emma's team also will get banned. My team will also get banned. So we lost months of work by not following the rules. These are two simple rules for competitions. No multiple accounts. That means you're using only a single account on Kaggle, and do not share your code across the team. What you should do is to team up and collaborate, which is quite rewarding, quite fun. Cross-validate and experiment. A lot of options to experiment. Cross-validation is very important because otherwise what happens is, I'll try to explain, here, public leaderboard versus private leaderboard. You are making inference on the test set. So let's say if the test set has 100 samples, it's only giving you a result on 30 samples. The remaining 70 are still hidden, which will be revealed at the end of the competition. So if you don't cross-validate properly, your public leaderboard would be showing something else and your private is going to be going up or down. And it does happen often. You are either moved down or up. So luck does play a factor a little bit, but cross-validation always helps. Collaboration for competitions is usually on Slack. No meetings, no Zoom. So far, I've done so many competitions. I think it was only one time or we had a Zoom call or something, which was also not required. We team up regardless of the time zone. So I've worked with teams from all over, India, UK, a lot of Japanese Kagglers on Kaggle. I've worked with quite a few Japanese Kagglers. And there's quite a bit of time difference. So yes, these are just the collaboration rules or suggestions. This is my personal tools or tech stack for competitions. Python, PyTorch. People do use TensorFlow, scikit-learn, transformers on Hugging Face for text competitions. DeepSpeed, if you want to try distributed model training. Grady on Hugging Face for visualization or demo. Error analysis is also very popular. Uh, by error analysis, what I mean is you have to understand where your model is making a mistake and why. If you visualize, uh, you can probably make changes in your model training as to how or why the certain errors are taking place. So that's why the error analysis part is also important. You also want to track all the experiments that you're doing. Over the course of competitions, hundreds of experiments are very likely. It's not unlikely to have a few hundred experiments over a 2 to 3 months period. So a lot of people use weights and biases. I use Neptune AI. VLLM inference. So since the inference time is limited, we are always on the lookout for how to make faster inference. So that's where the VLLM comes into picture for the faster LLM inference. Compute is also a huge requirement on Kaggle if you're trying to do, especially the LLM competitions or large data sets. You're going to need a lot of compute. Vast AI, RunPod.io, these are popular choices for Kagglers. I personally use Vast AI quite a bit, but RunPod.io is equally good. Hyperparameter tuning is also important, especially if you're dealing with tabular models. And Optuna is the tool choice to do hyperparameter tuning. Usually people don't do grid searches. Optuna is the thing to use for hyperparameter tuning. Ensembles are also very popular. You can stack them. You can weighted average there is a method called Nelder-Mead. It's there in scikit-learn, I believe, or SciPy. So that's also very popular in pretty much every competition. IDE, Cursor, you need really good IDE. There's no stopping whether you use the best LLM you can get and you want to use the best IDE you want. Cursor works really well. Okay, now to the notebooks demo. I'm going to stop sharing and open my Kaggle page, but it would be great if you all have access as well to your accounts. And I can show you how on some of the features that are possible in Notebook. Let's see. Hold on. Okay. Is anyone going to be doing this with me, or are you looking for just the demo? Then I'll go a little bit slow and wait for you all. Okay, great. So you go to kaggle.com, make sure you're logged in. Go to code, go to new notebook. It's going to be a blank notebook. It looks like this. I'm going to open up my list. I have a list of things that I wanted to show. So the interface that you see here is very similar to what you would see in a Jupyter notebook. I'm going to delete all this. We don't need, I'm going to probably keep just NumPy and I'm going to call this demo. Let's call this demo. This is the way to start the session right here. Right now, the notebook doesn't have any data sets attached. So we are going to go ahead and first thing to do would be to find a data set that we want to work with. You can select competition data sets, actual data sets. You can even select other notebooks, models, scripts. I'll go ahead and select dataset, and I'm going to go ahead and select a dataset called, there's a Carvana dataset. Carvana don't get kicked is the dataset. Hold on, let me find it. Yeah, the dataset is called don't get kicked. So if you search for don't get kicked, hopefully it pops up. Yeah, this one. Actually, it's not this one. Sorry. It's actually this one. Predict if a car is, but you can actually honestly take any dataset. Predict if a car purchased at auction is a lemon. So that's the task here. And I'll just put the URL. They did not find it. Wow. This has to happen during the demo. I'm going to pick a competition dataset, okay? It's called a backpack prediction challenge. It was hosted a few months back, 2 months ago. So I'm just going to pick this one. We are not doing actually more looking at the data set, but rather I'm showing you how to connect the data set. So here you will see the data set and you can actually copy the path. Let's say you want to see how the data set looks. You want to say df and the path comes here and you can do whatever things you want to do with the data set. Please no. Oh, we actually want this CSV file. 300,000 rows, 11 columns is what it has. So the other things that I do want to show you here is if you scroll down on this notebook here, you're going to see some session options. So there are session options which says your GPU, which one you want to use, GPU P100, twice T4 or TPU. They also offer TPU. I use less TPUs, but GPUs are very popular. Language, you can select Python or R. I mostly go with Python. They have the option for internet on or off. We have to turn it off if you are trying to participate in a competition and trying to submit. So this one has to be off. You can link it to GitHub. We have not linked it right now to GitHub. You can schedule the notebook to run. So you can frequency data updates once daily. So like the ones that I showed you, the earlier notebook, Kaggle in numbers, is this notebook here. This one is run every day. So if you see the logs, it'll show you when it was last run. Actually, here it is. It shows somewhere. The script was last run on Monday 12th. And it basically is scheduled notebook and it gives you all the Kaggle information. So 24 million accounts and how many masters, how many contributors and so on, how many staff members. Kaggle has 83 staff members, things like that. So this is a scheduled notebook. So people don't have to run it every day. It's automatically run. Let's see, what else? Yeah. So let's say I made some pre-processing and I want to save a file, okay? I did the data set, so I'm going to save the file. Let's call it demo.csv. And if you look here, the file is here, demo.csv. And it is, you can also see the file right here in Kaggle working directory. This is where that 20 gigabytes I was talking about. Right now, it's only using 22 megabytes. This is where our file is demo.csv. If we save this notebook, you can click on, by the way, you can have multiple versions of the notebook, which is kind of cool. You don't have to create 100 notebooks, but you can have 100 versions. So I'm going to save the notebook and we can see the file persist outside of this session and you can use it in some other notebook as well. There are other things here going on. So let's see. You can set a notebook as a utility script. A lot of us like to work with .py files. you can create the .py file right here. Instead of having a notebook interface, it'll become like, I can set this as utility script. And I can also set the editor type to script. So now the editor looks no longer like a Jupyter interface. It's a .py file. It will be saved. And you can use this .py file in another notebook as well. I'm going to change this back to notebook right now. And let's go and see the file that is there. So this is our notebook. If we see the output, the file that we created, demo.csv, is there. You can directly transfer this file to a new notebook, a new data set. You can download the output however you want to use it. But it's just a one click here at the output once the file is saved. We go back to the editor. There are some cool versions here, cool things. I really like, let's say we want to make a change to, I remove this index false, okay? And I'm going to save it again. It shows you the difference between two versions, which is very helpful and kind of cool to see the difference. It's going to save it and we'll be able to see it. Let's see what else. Yeah, privacy control. Oh, this one. So here you can see what accelerator we are using: CPU, RAM, disk space, sessions, how long. GPU will also show up here if we use it, things like that. So if you go back here, and you can see let me see if it shows, let's go to viewer. And you go to click on version, and here you click here, and you say compare version, and you say choose another version. It shows you the difference between the two versions. If we had 10 versions, we could select anyone from version 1 and version 10, what's the difference, and it'll show you. Very nice feature, very useful feature. I use it often. Let's see what else. There is a share button here. By default, the notebooks are private, but you can make it public. If you did something really cool, you wanted to show off, make it public. Otherwise, if you're copying from somebody else's notebook, you want to keep it private because you don't want to duplicate whatever is already there from the competition by just making another copy of it. Then you keep it private. Anything new you want to you share, you can make it public. You can also share with your teammates the notebook. By default, the notebooks are shared within the competition because you're sharing the dataset also. But you are allowed to share edit rights also with other people. So this is what I mean. So when you share, when they say no private sharing, here you should share with your team, not outside the team, because Kaggle knows who you're sharing with, who you're teaming up with. So if you want to share it within the team, but not outside. Oh, let's see what else is there. Yeah, I think that's about it. Do you all have any questions here?
I just have one question. Could you go over the split versions? I didn't see
Sure.
it
Yeah.
'cause I
So
was
you
trying to
go back
replicate
to
on my
the
side.
demo notebook again. You click on the version here, and you click on compare version, and you can see the differences. Two versions selected, and you can see the differences. So it's basically available in the front of your notebook. Once it is saved, you'll be able to view it.
Okay, thank you for that.
Sure. I'm trying to see if there is something. Yeah. So one of the things that this is, you might have seen this in Google Colab also, secrets. You can add your secrets here. All the secrets you possibly want to use, like your keys, Gemini, Hugging Face keys, all possible keys that you want, you can add it as a secret here. And you can use it in the code itself. And this feature is very similar to what you would see in Google Colab also. Um, there's some fun. This is also similar to Colab. There is a kitty running around just for fun. Then what else we have? Some of the very useful features are like sometimes what happens is you have a lot of output running, like let's say df.head, I make it 30, okay? So it's a long list of output. It can be anything. Maybe this is useful, maybe this is not. So what you can do is you come here and you click here. No, sorry. In the view, you say hide cell from viewers and hide output. So this is going to, if I say hide output, and now if I save this, you're not going to see the head output in the notebook that gets saved. You're only seeing it in the edited version, which helps in readability if you're trying to make your work public. Let's see the version 3. This is what we want to see. Anything you are interested in figuring out how to do this with notebooks or any other questions, let me know. So it shows us show hidden output. This is where the hidden output went. You can hide it. It helps with the readability. Like for example, output like this should be hidden. It's no good, not useful for anything. And that's the way to hide the um, output. You can actually hide the input also. For example, like if you don't want people to see imports, you hide the inputs also. Mm, and I'm going to just make it 2. And also we can hide the output for this. Mm, yeah, sometimes we need different packages that are not available in the environment. We can add packages in Kaggle. You can either do a pip install, like right here. Like for example, if I want to pip install something, it should be at the bottom. Uh, let's say I want a package called. First of all, we need to have internet on, and let's just do scikit-learn. Maybe it already has, and it will overwrite or something. So it's going to install it for you. The other option is to have they recently introduced package. I don't see it here. Where is this? I wonder where did that go? There used to be something called as install dependencies. I don't see it here. I don't know why. Maybe it is only for the GPUs. No, I'm not sure. I'll have to look up. But this is one way to do it. Or you can also import, let's say there are oftentimes for the competitions, since the internet is not enabled, you can import the packages from the notebook, from another notebook and download it here. So that's also possible. And we do all that often when you are actually working in a competition. I'm going to delete this because we don't really need this. Also delete this. I think that's about it. That's all the things that I wanted to show for the demo. If you all have any questions, let me know. Otherwise, we go back to the slides.
So I kind of have like a question regarding the competitions. So
Mhm.
like for someone new,
Mhm.
trying to like participate in these competitions, is there like a way for you to get into a team? Like, or like, I don't know how to like
Like, how
explain
do
it.
you form a team?
Yeah,
Uh,
like how, yeah.
y- you have to start working on the competition. Personally, I work on the competition for some time, see how it is going. If you, let's say, click on the competition, any competition, let's go for this one. You go to leaderboard, you're going to see people who are interested in teaming up by this symbol, contact team lead. They are looking for partners. Some people don't put the sign, but they are still open to teaming up. Some put up the sign and they are looking for partners. You usually look for, sometimes, let's say, look for people's profile. Let's click anybody's profile, okay? If they are, if they have all done, like, this this person will be willing to participate. There are competitors who do competitions only solo. I wouldn't approach them. They've always done it solo. They have like 50 solo competitions. They're unlikely they want to team up. Some prefer to do solo, some prefer to team up. So you look at and then you can always contact, uh, you go to the competition, any competition, let's say you're interested, you click on the profile and you can message them. Kaggle allows you to send a message, like somewhere there is a message button mm, on the profile. I don't know where. I think my profile has it. Um, I know I have contacted people via, or maybe it's the contact. It's over here, so you can actually click here, contact right here. So you can actually contact people via Kaggle. They give you like 20 emails a month or something, so you can actually contact 20 people over the over a month. Usually you don't do that. I mean, I probably do maybe once every 3 months or 4 months or something like that. For as far as teaming up is concerned, I usually work on the competition for some time on my own, maybe improve how I'm doing, and then decide to team up or not. And we're going to look at some of the questions related to the competitions uh, later also. So let me go back and share the slides again. Okay, so next is this is my personal competition case. I'll show you what happens behind the scenes in competition. It gets quite intense. So you be quiet and just focus on the work. Is what happens usually. The competition was called ED, Mining Misconceptions in Mathematics. So the problem was a diagnostic question. It's a multiple questions with 4 options, like this one. It's a math question. It has 4 options. One correct answer and 3 distractors are called incorrect answers. Out of this, one is correct, A is correct, B, C, and D are incorrect. The task was to identify if a student selects B, what is it that student doesn't know that prompted student to select 13 rather than A? So in this case, if a student selects the distractor 13, they have a misconception and carries out the operation from left to right, regardless of the priority order. They don't understand the priority order. We were given about 4,000 such questions and 2,500 of these misconceptions. So that means the misconceptions are specific, they are fixed, and they are 2,500. Whereas the training data, you can generate more training data, the test data looks very similar to training data, things like that. Um, 2,500 misconceptions fixed, 4,000 training samples. Hidden test set, which we were not given, is about 3,000 questions. So 1,000 questions, every question has a correct answer and 3 incorrect answers. We were also given what is the correct answer. The task was not to find what is the correct answer, but the task was to find why something is incorrect was the task. The evaluation metric was mean average precision at 25. What that means is we were to provide 25 options for every single distractor. Out of that, one will be correct. Since it is mean average precision, the order matters. So that means it has to be towards the beginning, not the 25th. The rank or the ordering matters. That was the task. It was a very interesting task. At one point, I told my partner, this is a very interesting problem, but I don't know how to solve it. And he's like, I agree, and I don't know either. And this happens often in competitions. We are clueless when the competition begins. We don't have solutions, and sometimes we don't have solutions towards the end also. Then we read other solutions, how they came up with it. So a very easy way to solve this problem would be to ask a LLM like a Llama 3.1, what misconception student has? Tell me why the student got this answer incorrect. The Llama would say it in their own words that student probably does not know that there is an order for the division or the multiplication and something like that. Then you do the cosine similarity for the Llama answer, as well as the 2,500 misconceptions that we were given, which was fixed. And it would rank, we hope that it would rank well. It did give us some result, but it was not the best result. It was very naive approach. We were at the bottom of the leaderboard pretty much. We tried to, but by the way, on Kaggle, fine tuning works every time. You want to fine tune models to the data set because you are given the data set. You are allowed to generate data set. You are allowed to use OpenAI, Claude to generate more data. You don't have internet access for the inference, but you can train anything and everything. All that is possible. So usually people do fine tune. There is nothing one shot like ask a LLM or ask OpenAI there's no one shot. There is always a training involved for many, many competitions, or almost every competition, there's training is always involved. We started fine-tuning smaller embedding models. We tried many, many different approaches, many different models. Hugging Face is full of models, which one to pick, which one not to pick. It takes a while to understand those also, like which models oftentimes don't work. I mean, these models have some say that these models are at the top of the leaderboard here. You apply it to your own problem. Nope, not working. It has to be the domain specific. You have to understand the data very well to be able to come up to the right solution. So towards the end, we finally managed to have some solution. We used bigger models, 14 billion parameter instruct models. We had a re-ranker. Sorry, this should be 70B or 72B. 72B. Yeah, so we had two re-rankers, and initially we had 14B, 32B, and 72B. We were able to put all of this into a 9-hour inference. I had a great team. We did, this is what it looks like. This is the graph. What you see is the submission timeline. Over a period of September to December 2024, the team had 200 plus submissions. You can see that these are the submissions for all our teams. This is the public score. I haven't put the private score here, but this is what it looks. The zeros that you see are the errors, the mistakes we made at the bottom. We started somewhere here. This is what our naive solution would be, 0.18, the one that I described initially. We were here. Gradually, we stagnate here. This is kind of stagnating. And then We go bigger, we move up. We again stagnate, we goes even bigger, and we are getting there, getting there. Uh, we ended up with a score of 0.58 mean average precision. This information, by the way, the graph that you see is not public. I downloaded it from my data, converted it to graph. What gets public is how many submissions we made, and I'll show you that part as well. We finally ranked 13 out of about 1,400 teams. Had a great team. Nicholas from San Francisco, Abdullah joined from Dubai, Benedict joined from Germany. I was in Atlanta. We posted our solution link also. We also deployed partial code using Model Labs. Model Lab is a great tool if you want to try to deploy something or showcase how things look. Use Model Labs. I like it. You might have, I mean, if you're new to Docker and all, you don't really need Docker, but it's a pretty good tool to deploy. Okay, this is just, we are almost at the end. I just put the links here, all the links. This one I did not go through. There is a state of ML competitions report. If you go through this report, it tells you what people are using to win the competitions. I think this is a very good report because it tells you what works in the industry, what is working, what is not working with all the new releases, new products, new APIs, new tools, things that come up. You don't know which one to use. But I think this is a pretty good report that tells you what actually works on the competitions. Okay, the last one, this is a meme. So I worked on a competition called Identify Contrails to Reduce Global Warming. This was also a really good competition. So this was what we were trying to identify, the contrails from an aircraft. This was, by the way, a 450 gigabytes of data they had given. This was the largest data set that I've worked with. So if you do competitions, you will learn how to deal with very large data sets like 450 gigabytes. You will figure out how to work, and community will teach you how to do it. You don't have to like, oh, what do I do with this? No, they'll tell you. You read the posts, you read the code, you will understand what to do with that much data. You're so involved in the competition. I had a wall which had some scratches, and I'm like, it looks like contrails. I think the community also liked my meme, so I posted it online. These would be my key takeaways as far as learning goes. You have to study the top performing notebooks. I'm going to show you a couple of them, how to look for it. Implement top solutions. People post solutions as well. Also embrace the journey. There will be ups and downs. I have lost more competitions than I have done well in. There are times where there was one competition I remember. Four of us working. Like we were like usual competition. We have worked with each other in the past. We know what we were doing. But hey, this is competition. All of us are trying. In the end, nothing happened. We were way at the bottom somewhere. We learned we didn't cross-validate properly. We didn't have a strategy, good strategy for cross-validation. And that's what not doing a good cross-validation does. You go down at the bottom. So yes, you will have ups and downs. It happens. Collaborate and share. It's a lot of fun to collaborate with people. I like teaming up and have fun. Oh, questions, comments, you can reach me on this everywhere on the social. I'm going to stop the sharing. And maybe I'm happy to take questions. And let me show you, I wanted to show you some things here on Kaggle itself. So if you go, oops, that's not the account, that's not the page. Yeah. You go to competitions, You can actually see how many, let's go to the ED one itself. I'll show you how people post you go to leaderboard. It shows you number of entries. This is public information, like how many entries people make. By the way, you are allowed 5 submissions a day, so you cannot go beyond 5. Uh, so you can see like people have made like 400 submissions also. We missed gold medal by 1 rank. We were here. This was ED that I just talked about. The other things, like if you go, this is one of the really good solutions. You can go look up the solution here. The way to find good solutions, or you directly go from leaderboard, go to the top rank, and they'll be posting the solution. There is a button here. You can see the ending solution. Sometimes if you go scroll down, you are going to see they post the link to their GitHub. You can, I'm not sure if this one has, but at least it will have the inference link. This is a very good solution, very well explained in detail. So training code. This one, I would look for this kind of information. If you find some people posting good top training code, they are really useful. You won't find this kind of information often on Kaggle. Like if you look like 10 submissions, 10 solutions, you'll probably find 2 with the training code. But sometimes people do share, and grateful for their sharing. And I do go through every single thing that they write. Inference notebook, you can actually run them. So if you go here and look at their inference notebook, the first thing I usually do is I look at their input. If you see something like which says that private data source, so you want to make all these things public. Like this one has everything public, then you are actually going to be able to copy and edit the notebook and run it on your own and see what's going on. It is very easy nowadays to actually download the notebook and ask a LLM to tell me what's going on. You download the code, put it in Claude or ChatGPT or something, ask it to explain the code. They did fabulous job of getting summarized the notebook. And I do it often. I think this was one thing that I wanted to show in the competition. I think that's about it. I'm happy to take more questions. Anything that you have in mind?
One thing I think might be useful for newer folks to know is, would you mind talking a bit more about the public leaderboard and private leaderboard and what that all
Sure.
means? Thank you.
The private leaderboard is only revealed like if you go to current competition, like right now, currently running competition like this one, there is nothing on the private leaderboard. Isn't available yet, will be displayed after the competition closes. The public one is available. This leaderboard is calculated on the 25% of the data. The final results will be on the 75% of the data. So the final standings may be different. This is why we cross-validate. The score that we see here, all the score is on 25% of the test data. However, that may be like maybe 1,000 samples, maybe 10,000 samples. I don't know how much this has, but it is 25% of the overall. So the remaining is 75%. Different competitions will have different range. There are competitions which gives you the like a stock price kind of a thing. So you make your submissions, they collect data for 2 months, and then they run your code again and see how your submissions perform on a totally new different sets. Those are different types of competition. They do announce the rules. But for the most part, this is very common, 25%, 75%. Like I think this one had, let's see, this one had 28% and 72%. These are very common. So this one, the competition has ended. You can see the private and the public. When you see the private, you can see how many ranks these people moved up, how many ranks these people moved down, things like that. You can actually see sometimes people move up really like you will see this number of like hundreds of positions. Sometimes you will see hundreds of positions down also, and it's all possible. So this is why cross-validation is so important. You don't want to be below 27 and you don't want to be going down. You want to maintain your position. Um,
Awesome.
any
What other questions do people have about this? I know it's still kind of a lot to take in, but I think Rashmi's done a fantastic job of touring a lot of what Kaggle offers and how a beginner might get started. Anything that remains unclear to people or any tips you're looking for?
if you go to the competition, you can actually find the playground competitions. Like you can search for over here. No, actually here, getting started, or you can even say uh, there's playground fun practice problems. They host these series. These are tabular data problem. I think they are like once a month or something like that. And a lot of people keep doing it. Oh, by the way, there are two hidden secrets here. Sometimes people share, I'll show you who to follow. These people share a lot, and I'm a big fan of reading what they share. If you're looking for the notebooks, like which ones to good or not good, you go on the code tab for any competition, search by most votes, and you're going to see the useful notebook competitions to read. So this is how you figure out, you read this one, you read this one, you read this one also. This user, this long time user, uh, he's like 4 times like rank one, four. I mean, he's the grandmaster of grandmasters. Uh, he writes the discussion post and the code also, and they are really good. I You can search for like most votes. Uh, People like whatever he posts. Like you can see like 1100 votes, 800 votes. So this is how you find usually good content. Uh, and there are few users like him. You can actually go here and find more user rankings. Uh, some of these users do share quite a bit, and it's great to read the contents that they have. Uh, the one Chris Dio does one that I just showed you. There's one more user that also shares. Heng is the I can't see him on the leaderboard here, but it's probably there. Yeah, here. Heng shares a lot of information. You go here, go to most votes, but he only shares like specific. They only share usually specific to the competition. So you have to be following the competition to be able to understand what they're saying. It's not generic how to solve a tabular data problem. It's usually not a generic, but it is usually related to the competition. And they're great shares. Like you learn a lot from these kind of things when you read from the competition. Even in a given competition, you go to code in any competition. Right now we are looking at this predict calorie expenditure. You go and sort by most votes. You're going to see good kernels come up. And you should read through what these people are doing in the competition. The same thing for discussion. Uh, I actually read through, if I'm participating in a competition, I read every single discussion forum, every single thing that goes on here. But if you are just beginning, you don't want to read everything, but at least read the most votes one. There will be useful information in the uh, most voted discussion forums. And you have like pages and pages of discussion forums here to read through. This is how you usually find good content uh, to work through. And important thing would be to find the topic that you're interested in. You will do much better. Maybe you have a background in some RNA or things like that, You want to pick those kind of, or maybe this this is also a very niche topic. waveform inversion problems. Maybe you have a background, you want to pick these kind of things if you have a background, definitely. There are some interesting problems that they keep coming up. They have a lot of community competitions also. Hosting community competitions are a great way for students to learn in the class as well. So instead of having homework as homework problem, give them a Kaggle competition to work on. And you can host your own. I've hosted a lot of competitions for students. There are some simulation type competitions. If they are your interest, you can you go to the leaderboard. They actually show you how the simulation works. It's not showing right now. Maybe you have to search for the simulation competition. They're like games. If you're into that kind of simulation, you might be interested in those kind of competitions also. I can't find it, but sometimes they do host simulation competitions. And you can actually visualize how two teams are uh, playing together. Kind of fun. Other questions?
Alrighty, that might be the end for us, but I am again grateful to Rashmi for joining us. Thank you all for logging on tonight, and for anyone who's watching on the recording, thanks for tuning
Thank you.
in.
Thank you so much for having me.
Absolutely. We love having folks swing by, and it is fantastic to learn from people who have a lot of knowledge in really specific areas that they can share and we can learn from. So thanks once again. I hope to see many of you all next year in the speaker series, and look forward to that.
Thank you.